Hello everyone, I'm Namita and studying in Sri Venkateswara College of Engineering. Today I'm here to discuss about unguided transmission. First type of unguided transmission is radio transmission. Radio transmission is a method of sending information such as audio, data, or video through the air using radio waves. It is a key component of wireless communication system and is employed in various applications including broadcasting, two-way communication, satellite communication, and wireless networking. Characteristics of radio transmission. Frequency range. Radio transmissions cover a wide range of frequencies from very low frequencies to extremely high frequencies. Different frequency bands are located for various purposes such as AM and FM radio, television broadcasting, and mobile communications. Propagation. Radio waves can travel through the air, space, and some materials. They propagate in all directions from the source, allowing for communication over long distance. However, the propagation characteristics can be affected by obstacles and atmospheric conditions. Modulation. Information is encoded on radio waves using modulating techniques. Common modulation methods include amplitude modulation AM, frequency modulation FM, and phase modulation PM. Modulation allows the embedding of data onto carrier signals. Antenna systems. Antenna are used to transmit and radio signals. They can be designed as omnidirectional, radiating signals in all directions, or directional, focusing signals in a specific direction. The choice depends on the application requirements. Advantages and disadvantages of radio transmission. Advantages are wireless connectivity. Radio transmission enables wireless communication, eliminating the need for physical cables. This is particularly valuable for mobile devices, Wi-Fi networks, and applications where mobility is essential. Flexibility. Radio waves can travel through the air, allowing the flexible development in various scenarios. These flexibility is advantageous for applications such as broadcasting, emergency communication, and remote sensing. Long distance communication. Radio waves can propagate over long distance, making radio transmission suitable for applications like long range broadcasting, point to point links, and satellite communication. Disadvantages of radio transmissions are interfacing. Radio transmissions can be affected by interfacing from other electronic devices, competing signals, and environmental factors. Interference may lead to signal degradation and reduce community reliability. Limited bandwidth. The available frequency spectrum for radio transmission is limited. As more devices use the spectrum, congestion can occur, leading to reduced data rates and potential network performance issues. Attenuation and obstacles. Radio waves can be attenuated by obstacles such as building and follicle. They limit the effective range of the radio transmission and radio signal strength in certain environments. Another type of unguided transmission is microwave transmission. Microwave transmission is a method of transmitting information using electromagnetic waves in the microwave frequency range. This technology is commonly employed in various communication systems, including point-to-point communication links, satellite communication, and certain types of wireless networks. Microwaves have shorter wavelengths compared to radio waves, enabling them to carry high frequency signals. Characteristics of microwave transmission. Frequency range. Microwave generally refer to electromagnetic waves with frequency ranging from 1 gigabyte to 30 gigahertz. These frequency ranges fall between radio wave and infrared wave. Directionality. Microwave transmission is often highly directional. Antennas are designed to focus and direct the microwave in a specific direction, enabling point-to-point communicating links. Propagation. Microwaves can travel in straight line and are affected by obstacles such as buildings and terrains. Line of sight communication is a common requirement for Microwave links to minimize signal attenuation. High data rates. Due to the high frequency, microwaves can support high data rates, making them suitable for applications that require significant bandwidth, such as long distance data links and high capacity communication channels. Advantages and disadvantages of microwave transmission. Advantages are high bandwidth. Microwaves can carry high frequency signals, allowing for the transmission of large amount of data. This makes microwave transmission suitable for applications with high bandwidth requirements. Low attenuation. Compared to low frequency radio waves, microwave experience lower atmospheric observation attenuation. This property allows for the longer distance transmission without significant signal loss. High data rates. The high frequency of microwaves enables the support of high data rates, making them suitable for applications such as long distance data links and high capacity communication channels. Disadvantages of microwave transmissions are line of sight requirement. Microwave signals typically require a clear line of sight between the transmitting and receiving antenna. Obstacles such as building and terrain can distort signal propagations, requ- requiring careful planning of the transmission path. Weather effects. Weather conditions, particularly heavy rain, can attenuate microwave signals, affecting signal strength and reliability. This can be challenged in regions with frequent adverse weather conditions. High equipment cost. The equipment required for microwave transmission include high gain antennas and specialized transceivers can be relatively expensive. This may impact the overall cost of the deploying microwave communications. Infrared transmission. Infrared transmission involves the use of infrared light wave for communication, while often associated with remote controls for electronic devices. Infrared technology has applications beyond consumer electronics. Infrared communication is used in various contexts, including data transmission between devices, security system, and short-range wireless communication. Characteristics of infrared transmission. Frequency range. Infrared transmission exists in an electromagnetic spectrum with wavelength longer than the visible light but shorter than the microwaves. In terms of frequency, it ranges approximately to 300 GHz to 430 terahertz. Propagation. Infrared signal traveling a straight line and they are affected by obstacles. They require a direct line of sight between the transmitter and the receiver for the effective communication. Obstacles such as walls can block infrared signals. Short range. Infrared communication is typically short range, limited to few meters. This makes it suitable for applications like remote control, short range data transfer, and proximity sensing. Security. Infrared signal are less likely to infrared with or be infrared by other electromagnetic signals, providing a degree of security for data transmission. Our line of sight transmission can be also limited for security. Advantages and disadvantages of infrared transmission. Advantages. Line of sight communication. Infrared communication requires a direct line of sight between the transmitter and receiver. These characters can be advantages for certain applications where focused secure communication is desired. Low interference. Infrared signals are less prone to interference from other electronic devices compared to radio frequency. This can contribute to more reliable communication in environment with multiple electronic devices. Security. Infrared communication provides a level of security as signals are less likely to be intercepted compared to radio waves. This makes it suitable for applications where privacy and security are important. Disadvantages are short range. Infrared signal have limited range, typically a few meters. This can be disadvantages for applications requiring communication over long distance. Line of sight requirement. Infrared signals require an unobstructed line of sight between the transmitter and the receiver. This limitation can be problematic in scenarios where obstacles may interfere with communication path. Accessibility to environmental facts. Environmental facts such as ambient light, dust, and fog can affect the performance of infrared system, especially sunlight can interfere with the infrared signal. Light transmission. Light transmission refers to the use of light waves, typically in the visual spectrum, for communication purposes. Light-based communication technologies are diverse and include fiber optical communication, visible light communication, and other optical communication methods. Light transmission is widely used in telecommunication, data networking, and emerging technologies such as light fidelity. Characteristics of light transmission. Wavelength range. Light waves used in transmission can span a broad range of wavelength. In optical communication, this often includes the visible spectrum 400 to 700 nanometers and sometimes extend into the infrared and ultraviolet region. Propagating medium. Light can be Light can be transmitted through various mediums, including air, gas, and optical fibers. Optical fibers are commonly used for long distance and high capacity data transmission. Speed of light. Light travels at an extremely high speed, allowing for the rapid data transmission. In optical fiber communication, data rates are often measured in gigabytes or terabytes per second. Directionality. Light transmission can be highly directional, especially the point to optical communication. Fiber optics, for example, uses focused beam of light to transmit data over long distances. Advantages and disadvantages of light transmission. Advantages: high data rates. Light based communication technology, this fiber optics, can support very high data rates. This makes them suitable for applications requiring large bandwidth and faster data transfer. Low attenuation. Light signal can travel long distances with minimal signal loss, especially in the optical fiber communication. This property allows for efficient data transmission or overextended distances. Immunity to, immunity to extra electromagnetic interference. Light signals are immune to electromagnetic interference, which is common concern in radio frequency based communication. This makes light transmission suitable for an environment where interference is a critical issue. Disadvantages: line of sight limitations. Some light based communication technology, especially those using visible light, may have line of sight limitations. Obstacles can block the transmission of light, requiring careful position of equipment. Infrastructure cost. The installation and maintenance of the infrastructure of the light transmission, especially in the case of optic fiber networks, can be expensive. This includes the cost of laying and protecting fiber optic cables. Fragility. Optical fibers can be delicate and are susceptible to damage if mishandled. This fragility can be a concern, particularly in environment where cables may be subject to physical stress. Conclusion. In conclusion, the diverse transmission technology of radio, microwave, infrared, and light each offer distinct advantages and limitations. Radio transmission stands out for its ubiquitous wireless connectivity and scalability, but faces challenges of interference and limited bandwidth. Microwave transmission excels in high capacity point to point links with its high data rates, yet demand line of sight and susceptible to weather effects. Infrared transmission, characterized by its line of sight communication and low interference, suits short range application but face limitations in the range and environmental factors. Light transmission, including fiber optics, provides secure and high speed communication over long distance, although infrastructure cost and line of sight constraints are considered. The choice among these techniques hinges on specific application requirements. Consider factors such as data rates, range security, and environmental conditions. Thank you.